Hello, everyone, and welcome to our talk, The Ultimate Guide to Cloud Run. We're engineers on the Cloud Run team. I'm Sara, a developer relations engineer, and this is my teammate.
Hi, I'm Wietse.
And we put together this talk to introduce you to Cloud Run for those who are new to it. Cloud Run is Google Cloud's serverless engine. With Cloud Run, you can run any container on demand without any infrastructure management. No VMs or clusters to manage. In this talk, you'll see an overview of Cloud Run, including the most common features to get your apps up running in production. To get started, Wietse will demonstrate how to deploy a web service on Cloud Run.
That's my cue. Let's go to the demo line. Can we go to the demo line, please? Yes, thank you. So this is Google Cloud, and I'm going to navigate to Cloud Run, which is right here. Maybe zoom in a bit. Yeah. So you can see that we are going to have many small little demos during the talk, followed up with a few slides. But first, I'm going to show you how to deploy a web service. So the service I'm going to deploy is Nginx. It's a web server, but it's not a real app, but it's like to show like if you have a container and it can handle web requests, you can deploy it to Cloud Run. So I click deploy container, and then I fill in the container image URL, Nginx. So that goes straight from Docker Hub. And I pick a region where I want to run it. Well, let's do Las Vegas because, well, that's close. And I will choose to allow public access because, well, it's not a demo if it's not live, right? I can set auto-scaling constraints, right? So it will scale to 0, and I can give a maximum number of instances too. And another important setting for Nginx is the container port, because it runs on port 80. I don't want to wait on port 8080 and nothing happens, and we wait for 4 minutes. It's going to be the most boring demo of the day. OK, this all looks good. I press create. Can we? Yes, thank you. And boom, we have an auto-scaling website on Google Cloud on an HTTPS URL. They look very underwhelmed.
I'm excited. Yeah, there you go.
Thank you.
Hey, there.
I mean, I like this. Like all the things you get out of the box. I entered the container image URL, and I have an HTTPS endpoint. I like that. This is what sold me on Cloud Run when we launched the product in 2019. Yeah, let's go back to the slides.
The demo used a Cloud Run service. As a developer, you deploy a container image, and you get an HTTPS endpoint back. There are 4 types of Cloud Run resources: services, jobs, worker pools, and functions. A Cloud Run service follows purely request-driven scaling. Instances within the revision are scaled out behind a Google-managed load balancer. It provides out-of-the-box URLs and HTTPS. The built-in traffic splitting and gradual rollouts let you reliably deploy new versions of your app without any disruptions or SLO breaches. A Cloud Run service has multiple trigger sources like HTTP2, gRPC, events, and web sockets. Then we have Cloud Run jobs. A Cloud Run job is a container that runs to completion. They are not triggered by HTTP requests. If you have a really large job, you can split it up and run it on multiple containers in parallel. Cloud Run jobs can be executed manually or automatically on a schedule. And you pay only while the job is being executed. A worker pool has 1 or more instances continuously running in the background, waiting for work. In contrast to a Cloud Run service, worker pools do not have an HTTP endpoint and do not support auto-scaling. And lastly, we have Cloud Run functions. A function is a single method that handles a request via an HTTP endpoint. And when you deploy your function, you automatically use Google Cloud's build packs and Cloud Build to build container images from your function's source code. You have 3 deployment options. So first, if you've already containerized your code, you can deploy your container image directly to Cloud Run. Second, if your code is in GitHub, you can set up CI/CD and deploy from there. And third, let's just say you have your source code, and maybe you don't have a Docker file. Cloud Run uses build packs to automatically build a container image from your source. You'll learn more about build packs later. Every time we add a region to Cloud Run, to Google Cloud, Cloud Run is available from the start. So yeah, let's go and see another demo.
More demos. I like demos. I mean, the slides are good to reinforce all the concepts. But
it's about the demos.
It's the demos. Just showing the product. It's always nicer. It's going to be a bit more unusual demo because I want to make it a bit more collaborative. So I created the Cloud Run service, and each of you is going to get a container instance in the service. So if you scan the QR code, you know what? I'm going to do it myself too. You see all those boxes? That's you. Everyone gets their own container image. And you know what I like? How fast they get added? Like, this is auto-scaling, like, visible. You can pick an emoji, select a different color, and then on the last step, you can see live system metrics, because as long as you have the page open, you get streamed down the system metrics, so you can see, like, what region it's running in, how many memory is used on the container, what the uptime is. And you can see a few of those hourglass containers appear. Those are containers that, like, people, they click away, they leave the page, and the container gets idle, and it stays running for someone else to connect to. And one nice thing about Cloud Run is that you don't pay in the default pricing model for those hourglass containers. So you pay really only for the container time while it's actually handling a request. Someone is really having a hard time deciding between the crab and the frog. Well, the demo worked. Like, it's like you cannot practice this, so I like that it's worked out. They don't like it. It's very silent. Like, as a speaker, I do like it when I have some external validation. Like, you can say, yeah, that was a good demo. That was not too anti-yet. Is this like a cultural thing? Like, I'm from the Netherlands. We are always very cheerful. Like, no? OK. Sarah was like, please get back to the script. We've talked about this. We've talked about this. Let's do more slides.
Yeah, let's go back to the slides. Good job. Good job.
Thank you. Oh, this is me again. Yeah. So I want to explain the architecture of the demo, right? It starts with a Cloud Run service. And I've set the maximum concurrency setting to 1. And that means that every container is going to handle 1 request at a time. You can set it higher, and then it works like a usual web application would. That one container can handle many requests at the same time. But for the purposes of this demo, it's 1 request is 1 container. And then the front end on your phone opened a WebSocket connection. So each of you connected to an individual Cloud Run container in the Cloud Run service. And then over this connection, the phone sends commands to choose a background color or change the emoji. And the container instance sends system metrics back every 2 seconds. So that's how it worked. And all the container instances, they stored their state in a Firestore database, right? So every container instance wrote 1 Firestore document. And then the presenter view that I showed on the screen, it was just the Firestore SDK with JavaScript visualizing the images real time, the container instances real time. So that was autoscaling in action. And I'm going to do another demo. Can we show the, yeah, because what I want to show too is now, like, take a step back, like, how do you deploy a change to Cloud Run? So I built another app. It's like blue background, and it says this is a blue page. And this is like an app I've been working on for a while. And I am using the editor in Google Cloud, the Cloud Shell. Like if you click on this terminal icon, and if you're in the Cloud Console, you get like a shell, a terminal. But there's also then a button to open editor, and then you get like a complete Visual Studio Code instance. And you can like build little apps with it. There's Gemini CLI in it too. It's super useful. So this is also where my app is. It's an index.html file and a Docker file that says, hey, use Nginx, and this is the Nginx config. I'm not overwhelmed by the complexity of this app, but that's not the point, because I want to show how to deploy this. So I go into my terminal, I do a gcloud, run deploy. This is a different way, right? I showed web console, now using the shell. Region, US West 4, there we go. And I confirm the source code location and the service name, Wietse. Oh, I'm deploying my home directory. Let's not do that. You see live demos? It's always fun. This directory, service name is color. There you go. And I will start deploying. Can we go back to the slides so we can explain what's going on now?
So let's break down what that gcloud run deploy command does for you. It first uploads the sources to a cloud storage bucket, and then it kicks off a build in Cloud Build. And note, if you don't have a Docker file, then BuildPacks is used to turn your source code into a container image for you. And BuildPacks is the open source version of, the technology that powered App Engine since 2008. And again, you do not have to run these specific commands. That is done for you by the gcloud run deploy command. Once the image is built, it is pushed to Artifact Registry, Google Cloud's container registry service. Then Cloud Run creates a new revision, importing the full image. You'll learn more about revisions on the next slide. And lastly, 100% of traffic is automatically migrated to the new revision as soon as it is healthy.
Yeah, let's go back to the demo and see. Hopefully my update was deployed. Let's refresh. And thank you.
They were excited about that.
Yeah, no, I was like, I'm happy now. We're like, you're my best friend now. Thank you. I'm afraid I made I introduced a bug in my app. It's now a red background, and it says this is a blue page, which really suits my sense of humor. But like, if you don't get it, it's no worries. I'm Dutch, so I have that very often. So let's see. So my change was a new revision, right? So that's my new version right there. But yeah, I want to do a rollback, right, to my previous known version that had the blue background in the text. This is a blue text. So I will select my this revision, click on Actions, Manage Traffic, and then instead of sending all the traffic to the latest version, I will choose to send all traffic to one revision, which is the last one that I know that worked, which is number 12. There you go. I save that. And then I'm hopeful that my production site is back and stable.
Hey.
Thank you. Like, they're getting just as excited as I am about this. This is good. Let's go back to the slides.
What do we mean by a revision? A revision is an immutable or read-only copy of your container image and settings. Every time you make a change to Cloud Run, it creates a new revision. Cloud Run has support for configuring traffic migrations, allowing you to do rollbacks or other traffic migrations. And Cloud Run automatically pings the revision on the default port to verify that it is healthy or ready to go within a certain time frame. This is called a startup probe, and you can configure this startup probe as well. For logging, you can write to standard out there is no need to use the cloud logging client library. And you can use structured logging as shown here. We recommend using a library for your particular runtime. And with structured logging, you can write queries in cloud logging and filter on those custom attributes. For example, you can query on user ID as shown here. One of the most common errors is the container failed to start on port 8080. So a few tips for this. Look in the logs for any crashes or errors that appear before this message. Then, if everything looks good, verify that the port environment variable is configured to match what your app is expecting, like the Nginx demo with port 80. And then third, or lastly, maybe your container is just taking too long to start, hence the startup probe failed. See if you can move any database connections outside of the container startup scope, or look at other options for loading a large language model in our GPU best practices guide. Now, you probably want to test things out before you send traffic to it. So let's see preview deployments.
Yeah, Yeah, so because we don't want this to happen again, right? So immediately confronting everyone with a red background and the text that doesn't match it, I don't want to repeat that again. So here's what I'm going to do. All the traffic is still going to this old revision that I know is working, like the blue one. So now I'm going to push a new version. And here's what I'm going to do. I'll change this to be green. Oh, wow. Red, green, green. Thank you. There's this thing if you're sitting and everyone is like trying to type, everyone is watching. Green page. OK, there you go. I save it, and I deploy the new revision. Same directory, same service name. Now we wait. This is never awkward.
Never awkward.
No.
The silence.
The silence. I'm always enjoying the silence on the stage.
It's the best.
Best, yeah.
Time just goes by very, very quickly.
Very quickly.
When you're on stage.
Absolutely sure, yeah. Oh, it's deployed. Now let's check if it's still blue. It is still blue, not green. This is good. I'll check out my new revision, and it is there. Now, I can create a revision tag that always points to the latest revision that I can use to preview this new deployment before I send all my production traffic to it. So I went to revision tags, clicked on the plus symbol, and now I get this new URL that I can use, and it says this is a green page.
Okay.
And now I know this is safe, right? No bugs. So now I go to actions, manage traffic, and I can do two things. I can, well, live on the edge again and send all the traffic to the latest revision, or I manually select this new revision, and I watch how Cloud Run will gradually migrate all the production traffic, which is just me, so it should be pretty fast. There we go.
Yep. Awesome.
Yeah.
All right, let's go back to the slides. To recap, there are two steps to using preview links. First, manually pin production traffic to a specific revision, and second, create a traffic tag pointing to the latest revision. Now that we're done building our app, let's discuss what you need to know in production. For example, public domains, auto-scaling, and pricing. First is public domains. By default, you get two run.app domain names. The first one shown is the new deterministic URL, and the second one is the older URL that uses a project hash value. Then, if you want to use features such as multi-regional load balancing, manage SSL certificates, or enable Cloud Armor or set up a CDN, you'll want to create a global external application load balancer. And lastly, we have in public preview a custom domain mapping feature. So we've shown you a lot. Yeah, we've shown you a lot in the Cloud Console, but we want to show you how to give your agent access to Google Cloud Developers documentation.
Yeah, because let's be honest, like I don't spend a lot of time in the web console these times. I also don't spend a lot of time reading documentation anymore because I have my favorite agent for it, Gemini CLI. Now, one thing I like to do is ask it about new features, but I'm first going to show you, if you don't do anything special, what is going to happen if I, for example, ask without using external tools, because otherwise it will find the answer, what GPU types are supported by Cloud Run. Exploring GPU support, investigating GPU availability, confirming, and now the answer is going to be Google Cloud Run supports NVIDIA L4 GPUs, provides the GPUs to accelerate compute-intensive workloads such as machine learning, inference, and video processing. This is a great answer, but it is wrong because it's outdated.
Outdated. And
there's one thing I'm going to show you, and maybe you're already familiar with it, but there is this developer knowledge MSP server. I can connect it to Gemini CLI, and then I give Gemini CLI the ability to search in the Google Cloud Docs and use those answers that it gets back to ground the responses. So I configured this server in my Gemini CLI instance, so it can query and can get documents and can search. And now, if I ask the question again, using the MCP DevDocs server, answer again. It's going to give an answer that is grounded in the most, so it wants to send a query to it. I allow. It will give an answer that's grounded in the most up-to-date information in our docs. Yep. And which is, we have two GPU types now in Cloud Run. It's the L4 GPUs, and now also recently GA, the NVIDIA RTX Pro 6000 Blackwell. And you can do this for many different things because code snippets and G-Cloud examples are also in our docs. So if you have a Node app and you want to debug why it's failing in production, you can ask Gemini CLI, hey, figure out in cloud logging why it's failing and fix it. And it will use all the snippets in our docs to help you faster. So I really like this. Let's go back to the slides, yep. I guess, yeah.
Now let's move on to adding more Google Cloud services to your application. The way you want to do this is by using the client libraries. It's not only convenient to use a client library, but you also do not have to manage API keys. You just initialize the client libraries as shown here, and authentication is done for you using a strategy called Application Default Credentials, or ADC. The Google Client Libraries automatically use ADC to find credentials. It's based on the environment the application is running in. Then ADC uses those credentials to authenticate to Google APIs. Let's say you have a Cloud Run service running in production. You set the service account as the identity of that Cloud Run service, and you grant this service account permissions to use Google Cloud APIs. The client libraries automatically use that Cloud Run service account for authentication. And here's how that would work on local hosts. First, you authenticate using gcloud auth login. Then you would run gcloud auth login application-default, which stores your user credentials. The client libraries can now find the user credentials and use them to authenticate to Google Cloud APIs. So your take-home message is when you use Google's client libraries, authentication to Google APIs happens automatically for you. Although client libraries are great for avoiding downloading API keys, sometimes you do need API keys. Secret Manager is a secure and convenient storage system for API keys, passwords, certificates, and other sensitive data. So let's see a demo of Secret Manager in action.
Yes.
So let's go to the demo.
I'm at your service. Yeah, so Secret Manager, my precious. Yes, I created another service that I will never recommend pushing to production because it will just list all the environment variables. I guess it's very stupid. Like, you would not do this, right? But for the purposes of this demo, it is super useful because what I'm going to do is I'm going to take a secret in Secret Manager and expose it to my Cloud Run app as an environment variable. And because I want to see the result like of this secret appearing here, I built this app. But don't do this in production. Like, environment variables are not supposed to be displayed like this. OK, so Secret Manager, you can find it in the Security Command Center nowadays. It is right down here, Secret Manager. And I have a bunch of secrets. Like here is my super secret. I can edit it, create a new one. And only if the user account that is logged in here has the secret accessor role, I can view the contents of the secret.
And it's the assessor role, not the viewer role.
Yes.
The viewer role lets you see the Cloud Console, but the assessor actually lets you see the contents of the secret.
That's a very good addition, thank you. Here's my environment print service. Now I can go to Edit and deploy a new revision. And then to Variables and Secrets. And reference the secret as an environment variable. Now what's a good name? Good name. This is what happens if you don't give me input. I'll choose my secret, and then I pin it to a version. I click Done, and deploy. Now, there is different ways to get a secret to your Cloud Run instance. Environment variable is one. Another one is mounting the secret as a file. So you get a file that you can access and read, and then you get the value of the secret. And the third one is using the client library, Secret Manager client library. Let's see if my secret is here. Good name, my precious. That's secrets in Cloud Run.
Secret Manager is great. Please, please use it.
Yes, yes. Don't put, because also, yeah, OK. But they know this. We don't have to tell them this.
All right, let's go back to the slides. What if you have an app that has shared data and all instances need to be able to access it? You can use volume mounts to make a Google Cloud Storage bucket or a file server, which appear as a local directory on every instance. Every Cloud Run instance has an in-memory file system. This means that every file written to disk uses RAM. If you need to write large files to disk, you can use ephemeral disks that don't consume your RAM. Let's talk auto-scaling. Let's say the first request comes in. It could be either the very first request or the first request after a long time. Cloud Run automatically spins up a container instance to respond to that incoming request. Cloud Run will automatically take down an instance when it has not received any traffic for a while, which is called scale to 0. And as traffic comes and goes, Cloud Run will automatically adjust the number of instances needed. If you want to prevent scale to 0, you can use minimum instances to keep a given number of instances warm or ready to go. And while auto-scaling is great, you may want to limit the number of instances that Cloud Run can auto-scale to in order to limit costs. You can enable Cloud Run service, function, jobs, or worker pools to send traffic to a VPC network using direct VPC egress, which does not need a serverless VPC access connector. So no serverless VPC access connector required if you use direct VPC egress. So far, we've only discussed having a public front-end website. But let's say you want to have a private back-end service that's not accessible from the public internet. There are two options. Option 1, you require IAM, authentication on the back-end service, and then grant Cloud Run invoker role to the public front-end service account to access the back-end service. The request from the front end to the back end adds an ID token for the back-end service to verify the IAM role. This is what the configuration of the backend service looks like in the Cloud Console. You'll choose to require authentication for incoming requests and select Identity and Access Management, or IAM, for, quote, service-to-service communication, which is what is highlighted in the screenshot in the UI. Or you can use option number 2. You can configure the public frontend to only send outbound or egress traffic through the VPC network. And the private backend is configured to only allow traffic from the VPC. And here is what the configuration for option 2 looks like for the backend service in the Cloud Console. So yeah, let's see this in action. Let's switch to a demo. You're up.
Yep, again. Here we go. Private backend. So I have a private backend and a public front-end service. I'm first going to prove that I cannot access the backend, because I know you're going to be like, OK, I trust the guy, but I want to verify. So no requests go to the backend. Yep. They believe me. This is good. Now, the front end, public front end. If I open the URL, it says, front end successfully routed through VPC. Backend says, hello world from private backend. It doesn't say 404, so this is good. The front end has access to the backend. Yep. Now, how would this look like? So the public front end, if you go to the networking tab, it will say, yes. It will say sending traffic directly to the VPC. So all the traffic that goes from the front-end container instances goes to the VPC, the virtual private network first. And if you go to the backend service, to networking, it will say ingress, so that's inbound requests, only allow traffic from your VPC. So front end sends traffic to the VPC. The back end only allows incoming traffic that is routed over the VPC. Now, if you're looking at this and you think, wow, this is not super user-friendly, I agree, and I have agreed since 2019. And I'm super excited to read this What's New in Cloud Run at Next 26 blog that published this morning, because there is this paragraph down here, which is a pre-announcement of Cloud Run service bindings. I'm going to highlight it for you. Coming soon, unlock seamless service-to-service communication for your scalable web service container thing, Cloud Run. I'm really excited about this, because that will mean that all the things I just showed you with routing to VPC and IAM things, that is just going to be transparently handled for you. Back to the slides.
Let's take a look at Cloud Run's pricing model. There are two models, request-based pricing and instance-based pricing. Let's start with request-based pricing, which is the default. You pay for container instance time. However, on Cloud Run, there is no charge for idle instances. These instances are not, by idle, we mean instances that are not receiving requests. What we do is slow down the CPU by a lot. And there's an additional fee for more than 1 million requests. And if you're using minimum instances and those instances are idle, they are charged much less than the full rate. And then the second option is instance-based pricing. You pay for the instance, so it's similar to request-based pricing, and you pay the full rate for idle instances. However, the price is less than the request-based price, and there is no per-request fee, which might be attractive if your service receives a lot of traffic. And also with instance-based pricing, idle instances and minimum instances are charged at the full rate. And we guaranteed idle instances are shut down after a maximum of 15 minutes. Now, if you're listening to all this and thinking, wow, this is complicated or hard to figure out your costs up front.
This is me. This is me, definitely.
Is this you?
Yeah, I see people with like eyes glazing over to like.
We have a feature to help.
That's great.
We have cost recommendations. So if you're using request-based pricing, in the Cloud Console for Cloud Run in the list view for services, you'll see a recommendation pop up, and it will recommend to enable instance-based pricing if that is cheaper for you. And to make this cost prediction, it'll look at your past usage. Cloud Run offers scale to 0 GPUs and is now generally available. And as you saw earlier in the MCP demo, we offer an NVIDIA L4 GPU and an NVIDIA RTX Pro 6000 Blackwell GPU. And let's get to one more demo. You ready?
One more. Is this the last one?
This is the last one.
Oh. Okay. Like, we have a nice rhythm going on here.
Yeah, maybe we've worked together for a few years.
Yeah, maybe we did. Yeah, what would the presentation at Cloud Next 26 be without an agent?
Yeah, I have an agent, yeah.
Yeah, so we added an agent to, it is my ADK agent here. So Google's Agent Developer Kit, if you're not familiar, is a framework that makes it easier to build agents on Google Cloud. And I'll show you the code. So I have a service deployed, and I go to the source tab, because if you deploy from source, like gcloud run deploy from source, the source is available in the interface too. So my agent is very underwhelming because it doesn't have any tools, right? Agent is a model with access to tools, and you call it in a loop, right? There's no tools here. It's just a system instruction that says you are a helpful assistant for Cloud Run for this demo. And I think you must be super excited to ask this agent now a few questions, so that's what we're going to do. Oh, and to deploy this agent, I used this gcloud run deploy command, like region US West 1, make it public, and set a few environment variables to make sure it could reach Gemini in the project. Now I'm going to get the URL of the service. Hello. Terminal, please. Yes. I'll put the URL of this agent service in an environment variable. I will start a session on ADK. I know terminal-based demos are super exciting to watch. It's just a bit of text, but it won't take long, I promise. And then I will ask my agent, my very underwhelming agent, what is Cloud Run? And the answer is going to be that it is a serverless platform that runs your code inside containers.
Yay.
No.